A very important derivative rule is the quotient rule. The quotient rule states that the derivative of f over g is equal to f prime times g minus f times g prime over g squared. Question 1 asks us that if y is equal to 2x plus 1 over x squared plus 3, find y prime. So first we need to construct a table with the values of f, f prime, g and g prime. So by default in any quotient rule question, the numerator is f and the denominator is g. So f is equal to 2x plus 1 and g is equal to x squared plus 3. F prime is the derivative of f, so the derivative of 2x plus 1 is 2, and g prime is the derivative of g, which would be 2x. So y prime is equal to f prime times g. F prime is 2. Keep everything in brackets. G is equal to x squared plus 3 and then minus, open a new bracket, f times g prime. F is 2x plus 1. G prime is 2x over g squared. Since our g is an expression, keep it in a bracket and then all over the power of 2. 2 times x squared is 2x squared and 2 times 3 is positive 6, and then again close the bracket, open a new bracket. 2x times 2x is equal to 4x squared and 2x times 1 is equal to 2x. Keep the denominator as it is. 2x squared plus 6 minus 4x squared, because here we have a negative symbol and then here we don't have anything, so by default it's positive. Plus and minus is minus. Again we have minus and plus, so minus 2x. The denominator remains the same. Now we can combine the like terms in the numerator. 2x squared and negative 4x squared, negative 2x squared minus 2x plus 6, and the denominator stays the same, so x squared plus 3 all to the power of 2. This is the final answer. Question 2 states that f of x is equal to x squared over cosine of x. F is the numerator and g is the denominator. The derivative of x squared or f prime is 2x. The derivative of cosine of x or g prime is negative sine x. So now we can plug in the values of f, f prime, g and g prime. So f prime is 2x, g is cosine of x, and keep the brackets as they are because you have to distribute the negative sign once you are done simplifying everything in the numerator. F is x squared and g prime is negative sine x. G squared is cosine of x squared. F prime of x is, opening a new bracket, we have negative x squared sine x. What I have done when I have multiplied these two values is I have brought this negative sign in front of the x. So now the negative sign is in front of the x squared and not in front of sine, all over cosine x squared. Now why I put everything in the numerator in brackets is because we have to distribute the negative symbol. So f of prime x is 2x cos x plus, because minus minus becomes plus, x squared sine x all over cosine x squared. If you want, you can still keep the numerator in brackets. F prime of x 2x cosine x plus x squared sine x over. For the denominator, you can also write it like this, cosine squared x, because cosine of x squared is the same thing essentially as cosine squared x. So this is our final answer. Question 3 states that if f of x is equal to 3x plus 1 over x minus 2, find f prime of x and f prime of 1. Now we have something new here which we didn't have in the previous questions, which is the value of x itself. F is equal to the numerator, which is 3x plus 1, and then j is equal to x minus 2, or the denominator. So f is 3x plus 1 and g is x minus 2. F prime is the derivative of f, so in this case it's 3. G prime is the derivative of g, which is 1. So f prime times g, f prime is 3, so we can start substituting the values. G is x minus 2 minus f, again keep everything in brackets, f is 3x plus 1 and g prime is 1, all over g squared. Now since g is an expression, not a single value, I'm just going to put it in a bracket and then put it to the power of 2. Now f prime of x is, we have to distribute the terms inside the brackets. 3 times x is 3x, 3 times negative 2 is negative 6, minus, again open a new bracket, and then 1 times any expression or number is itself, so 3x plus 1 times 1 is 3x plus 1, all over x minus 2 squared. And now we can remove the brackets from the numerator. So 3x minus 6 remains the same, and now this is negative and this is positive. We don't have a symbol in front of 3x, but that by default means it's positive, and positive times negative, or positive plus negative, minus 3x, and then negative times positive is negative 1, all over x minus 2 squared, the same denominator. So now we can add the like terms in the numerator. It's 0, we don't need to write it, and negative 6 minus 1 is negative 7, and the denominator remains as is. This equation will go over here. Wherever it says x, we have to write 1. Prime of 1 is equal to negative 7. The numerator stays the same. The denominator will become in bracket 1 minus 2, which is negative 1, and then keep the exponent of 2. 1 becomes negative 7 over negative 1 times negative 1, because negative 1 to the power of 2 is essentially the same as negative 1 times negative 1, which is positive 1. And any number divided by 1 is itself, so our final answer is negative 7. Question number 4 states that y is equal to square root of x over 2x plus 1. The equation for the quotient rule is y prime is equal to f prime times g minus f times g prime over g squared. To find our values for f prime, g and g prime, we first start with f and g. The numerator is f and the denominator is g. So f is square root of x and g is 2x plus 1. You can also write square root of x as x to the power of 1 over 2. Derivative of x to the power of 1 over 2, we get 1 over 2x to the power of negative 1 over 2. Then for g prime we get 2. Now we need to substitute these values into our equation. So f prime is 1 over 2x to the power of negative 1 over 2, and g is 2x plus 1. F, which is x to the power of 1 over 2, you can also just write square root of x, and g prime, which is 2, all over g squared. G is 2x plus 1, so we have 2x plus 1 squared. 2x plus 1 over 2 root x. When you multiply these two terms together, 2 root x, you can also write it as 2x to the power of 1 over 2, it's the same thing, over 2x plus 1 squared. Since this is plus and this is minus, it will become minus 2 root x. 2x plus 1 minus 4x over 2 prime x. This is because when I'm writing the numerators with a common denominator, this is what I get. To explain in further detail, let's say to give this the same denominator as this one, we can multiply it like so. Now when we multiply everything by 2 root x, we get negative 4x over 2 root x. We have a common denominator, and this is from where I got the negative 4x. And all of this, it goes over 2x plus 1 squared. Keep the denominator as it is. So here we have to add the like terms, so in the numerator of the fraction in the numerator. So 2x and negative 4x, this will become negative 2x, and then keep the plus 1 as it is, and then over 2 root x, everything over 2x plus 1 squared. Now to simplify this complex fraction, there is a technique in which you have to multiply the outer terms and the inner terms together. But as you may notice, the denominator is not a fraction. So to make it a fraction, what I'm going to do is I'm just going to put it over 1, because any number is basically the same as itself over 1. So 2 is equal to 2 over 1, or 3 over 1 is equal to 3. So if you want to cross multiply, or if you want to simplify a fraction but the other value is not in a fraction, you can just put it over 1. So now what you can do is you can multiply the outer and the inner terms together. There are many techniques to do this. This is the one that I like to use. So now for the outer terms, when you multiply these two values together, I'm just going to write it in a bracket, and then in the denominator you have to multiply these terms together. Now any expression times 1 is equal to itself, so we can just copy paste what we had before, and this should be a final answer. If you are given the value of x, you can definitely calculate it further, but I'm not given the value of x, so I'm just going to leave it like that. Question number 5 states that y is equal to x squared minus 3x plus 2 over 3x minus x squared. We need to plug in these values in our quotient rule formula. So f prime is 2x minus 3, g is 3x minus x squared, f is x squared minus 3x plus 2, and g prime is 3 minus 2x over g squared, and then again minus and open a new bracket, x squared times 3 is 3x squared, and x squared times negative 2x is negative 2x cubed. Negative 3x times 3 is negative 9x. 3x minus x squared to the power of 2. Now you can start removing the brackets, but be careful with the second expression because you have a negative sign in between, and positive will give you negative, and then negative times negative is positive, and you can write the expression of the terms as is, and then negative times negative is positive, again 9x, and then positive times negative is negative. Negative times positive is negative, so 6, and then negative times negative is positive, so positive 4x. Everything under g squared, so 3x minus x squared to the power of 2. Now you can start cancelling out the like terms. So 6x to the power of 2, 3x to the power of 2, negative 3x to the power of 2, and negative 6x to the power of 2. As you can see, these will get cancelled out automatically because 6x to the power of 2 and minus 6x to the power of 2 is 0. And then 3x squared and negative 3x squared is again 0. See for the cubed ones. So negative 2x cubed, positive 2x cubed. Again, this also cancels out to become 0. Negative 9x and positive 9x. Again, it cancels out to become 0. And the only terms we are left with now are these. Negative 6 plus 4x. Or you can also write this as 4x minus 6. And then the denominator stays exactly the same. And this should be your final answer. Now again, if you want, you can also write this as, but keep the denominator exactly the same, and this is also correct.